Hey, hello there YouTube, and welcome to my second video about circles. This video is going to cover circle theorems, which basically means a certain set of rules which will help you find out angles you do not know. Now, one example of this is angle at the centre is twice the angle at the circumference. So if we draw an angle from the centre and link this into the angle at the circumference, what this rule will tell us is that this angle B will always be half the size of angle A. So 2A is equal to B. So if angle A is 80 degrees, angle B will be 40 degrees. And that will work however much you move the angle. I mean, you could even move, imagine grabbing these 2 points, like on an iPhone, and just move it up there. So the angle at the centre will still be twice the angle at the circumference. The next theorem I'm going to draw is the theorem that an angle at the semicircle is always going to be 90 degrees. So here we have the radius of a circle, sorry, the centre of a circle. By the way, this point has to be at the centre of a circle for it to work. And it states that when you form a semicircle, so imagine this point here, we have a I'm not sure how you can see this, we have an angle at the semicircle. This angle here is always going to be 90 degrees. And also this is almost a derivative of this angle here. Because if you move these 2 points here up to the level of a radius and form a 180 degree angle, so if we say A is 180 degrees, okay, that's 2B, because obviously it's half, 180 degrees, then B is going to equal 90 degrees. Yeah, B is going to equal 90 degrees. So you can see how they interlink and work. Next we've got a totally different one. We have, just move this more to the centre. We draw two triangles off this arc, off this chord here, and as long as both of the triangles as long as both of the triangles touch the circumference here, these two angles are always going to be the same. And this will also mean these angles will be the same, because they all move. They all move together, so the angles will stay the same compared to each other. I mean, they will obviously change the amount of degrees, but they'll always be the same. I mean, these angles will be the same, and these angles will always be the same. They all interlink and join. The final one we have is a cyclic quadrilateral. So if we draw a chord here, we draw another chord here, And instead of this one, we're drawing the line anywhere. Okay. Sorry, I've drawn this line wrong. Forget this line here. And then we draw this. We draw another chord with the interlink. We need to make sure the interlinking line went through the diameter. And you're just drawing up the four corners to make a quadrilateral. This angle here will always be 90 degrees. So if we have two chords and the line interlinking them goes through the centre, so as the diameter of the circle, then this A and A will always be 90 degrees. And if you look here, we have this theorem here, angle in a semicircle will be 90 degrees, and we have it as well here. So basically they're all, quite often they're derivatives of this one, this theorem here, angle at centre. Just pause the video. Okay, sorry about that, my camera stopped recording for some reason. But anyway, like I said, these two, let's talk about this one here. So about how the semicircle angles add up to 90 degrees, just as a derivative of one, but it's actually got a special name. So this is a cyclic quadrilateral, and that's angles in centre is twice angle twice the angle at circumference, and that's just angle in a semicircle is 90 degrees. And yeah, so one more I've got to show you. So a very simple one. It's the tangent line. The tangent line compared to the radius of a circle. This is always going to be. Sorry, I need to move the camera down. So the angle at the tangent is always going to be 90 degrees compared to the angle compared to the radius. But yeah, so thank you for watching this video. If you have any questions or feedback, please leave a comment or send me a message. Thanks for watching this video. Please subscribe and like this video, and watch some more videos in this playlist. Goodbye.